So now let's take a few minutes to kind of drill down into this idea of natural lighting and some of the architectural tools and techniques. One that we talk a lot about, we're going to do a little bit of experimentation in our lab, is this idea of a light shelf, a way of reflecting light deeper into the building. And this is a relatively old concept, and I'm a little bit out to question its efficacy or its effectiveness. And a lot has changed in recent time. It used to be that the idea of driving as much natural lighting into the space was not only benefiting the sense of quality of the environment, the connection with the exterior, but to actually save energy by reducing the requirement of extra ancillary lighting systems. So that's changed in recent years because lighting efficiencies have gone way up with the advent of high quality LED lighting systems. We now get a lot of lighting for very little wattage, and that extra efficiency is a twofold benefit. It reduces the amount of energy needed, but it also reduces the cooling load. The heat that comes off of lighting systems typically in many areas of the country contributes to a cooling load. So I'm not selling or disselling the idea of light shelves, but you need to keep in mind some of the motivation for their creation was based on energy requirements or energy goals that are no longer pertinent or are reduced in their significance, so to speak. And there's also this trade-off between just the complications of creating these elements, the embodied energy and the things that are going to make them, and then weighed with the effectiveness of them. How effective do they actually produce the kind of lighting that we actually require? But with that said, this is the idea is to take exterior daylighting and drive it deeper into the building to create levels of illumination that meet the requirements for the work tasks that we have assigned. And we'll deal a little bit about this idea of how much light falls on a surface when we get to augmented lighting, so the LED lighting systems that fall on this. But anyway, this is a light shelf technique. And there's a little bit of a hybrid area here because you can also see that the light shelf is extending not only in to reflect the light off of ceiling systems, but it's going out and creating shading systems. So I wanted you to keep this idea, this play between the surfaces on the interior and exterior of the glazing system. And I think, is this the next slide? So this idea of clear story, I thought this is my tiny little house. And one day I happened to catch the lighting at a particularly nice time of day. The idea here was we have a lofted area that we have windows in, and they are up above the street level, so they create a sense of privacy. They light the upstairs areas, but they also are open to below, so they can drive light down into the interior space. And so here we have, you can see the windows here. You can see the sun coming from the other side windows, creating this lighting on a reflecting surface. And then if you look down over here, you can see that natural illumination is very diffuse and pleasant. So this is just a real-world example of that idea of using clear story lighting to illuminate interiors. And if you happen to be on the Alfred Campus, you'll notice there are this idea of louvers to control lighting is well illustrated. This is a great space to experience the student, meeting area where they have the cafeteria and all of the committee groups. I'm forgetting the name of it. Beautiful, large amount of glazing area with these baguettes or fins going across to control the lighting. And you can see the nice effect that they have in mitigating some of the sunlight that's coming in while still creating brightly lit surfaces. So all of that in mind is think about there's a whole bunch of effects that are going when we open our exterior of our building envelope to daylighting. So we want to pay attention to where the sun is coming from as respect to the glazing systems that we create. So this is the first idea of the path of the sun and the idea of the relationship of our architectural form to that sun. So here we have, let's say the green is new proposed buildings, and you can see how we have the summer sun very high in the sky. This yellow arrow is the path during the daytime. Summer solstice, the longest day of the year, the sun gets the highest in the sky. Winter solstice, the shortest day of the year, this path is the shortest and the lowest in the sky. So this light is driven very deep into the building envelope. In the summer, it's very high. There's very little penetration of the light deep into the building envelope. This is a reference back to our textbook, and I thought it's just a good idea of, or a good reference to this idea of many times we're building and our buildings aren't sitting on a clear open site. They have other buildings adjacent to them that affect the way light will play on our building and what access we have to light. So we get a chance to kind of experiment with this idea in our model space with interior lighting. This is what our lab is going to look like, our first lab. We're going to quickly mock up a small building, and then we're going to experiment by making a parametric window system, different size openings to create different illumination levels. And we're going to analyze those using an Autodesk product that allows us to render the surfaces in color according to the amount of illumination that is striking them. So here we have a natural look of the rendering system with the play of light, and then we have a enhanced illumination analysis. And this tells us the amount of illumination in lux, which we have not defined yet, but we will shortly. And then we'll take a look at the inside of actually adding a reflective light shelf. So here we can see this idea of a light shelf and then light reflected up above the window systems to drive illumination into the building. And in this case, this will be up to you to experiment with, but I had very poor correlation between the light getting reflected into the space to what the promise is of construction of light shelves. So we'll go through that full experiment. This will be your first introduction to daylighting maybe. In our modeling environment, Revit, we get to create the sun path according to the time of day and then visualize it, so that'll give us a little familiarity inside of the BIM modeling environment to how we use those tools. And so that's the start of this idea of analysis. This is some other sources. I think I have some of these hyperlinked. Maybe this one isn't. These are out of the textbook, but the idea here is just like we do in lab. Sorry, I went the wrong direction here. We have plugins within Autodesk to go out and do illumination levels. There are even more advanced programs that do finer looks at illumination. In this first one here, we have this idea of reiterations or iterations, looking at changing the glazing layouts, the time of day, the time of year, the lighting systems that we want, and then doing mathematical analysis to try and determine what's the optimum way for us to configure the lighting for that space. And here's another graphic kind of showing that exact same thing. So these are out of the textbook, and the connection to the kind of analysis we do is very similar. In this case, we're showing all reflected surfaces off of walls. One of the more popular techniques is really not to show reflected light off the walls, but just on the floor plate. And that helps to indicate where the best placement is for work surfaces that meet the illumination task with just natural lighting, so to speak, in areas that might be too dark and need auxiliary lighting systems. Another set of graphics out of the textbook, this idea of, in many cases, we have double loaded buildings, which means we have a building that might have a corridor and then another room to the other side. So we only can put windows on one side of the room. And then the idea is to figure out how much daylighting we can drive into the space. So we have a lot of adjustments with how high we bring the windows, to how much light, how far it can be thrown into the space. So it's obviously if we can put the windows higher in the space, we can get light deeper reflected off of the ceiling plane into the space. And there's some just general rule of thumb calculations that are available in that. And they're described more in depth in the reading. So there's always these, so light's a good thing until there's too much of it or it's at the wrong angle. So there's this idea of glare to keep in mind all the time. So we have intense surfaces, we have either no baguettes or no kind of sunlight control. So it's this really high contrast between dark spaces in the interior and bright spaces, and it creates this idea of glare. One of the more important downsides of glare is with computer monitors, especially those with highly reflective surfaces, which many do have. So here we have an example of a monitor reflecting the light of the window, and obviously this really degrades the quality of the graphic, the visual presentation that happens on the monitor. So placement of windows and orientation of work surfaces is really critical to creating workable interior environments. So we talked about this idea of inside light shelves and outside light shelves. I've already shown you this graphic in a previous lecture, but I wanted to bring it back up again because we've now thought about this idea of sun angle in our buildings, and this idea that we can control how much light we get in the negative way. So the winter sun, many times, much more desirable. We have less sunny days in the winter in many climates, and the idea of being able to drive that light deep into the natural lighting, deep into the building, is a really positive aspect. And then the idea of taking full advantage of the exterior shelf construction and or the roof overhang to control how much light can be driven into the building during the summer when we really want to keep that kind of intense heat out of our built environment. So this is a classical image you want to make reference to many times when you're designing your exterior glazed facades. So these are a couple of nice graphics about light shelves, placements of windows, and just as a way for you to think about how you communicate to your client and to other people on your project about your ideas about why you're locating window systems and other articles, like for instance the internal light shelf, the solar shade, so we have on the outside it's a solar shade, on the inside it's a light shelf, the idea of what the reflective surfaces are, how high the window is off the floor, how high it is with relationship to the ceiling plane. And I don't know if this one is hyperlinked, I guess not. Maxing daylighting in office spaces and dealing with glare. This one should be hyperlinked, and I'm afraid it's not. That one just went to it, so that's the same one. So it takes you into a really good article about this, where I pulled some of these graphics from. So I've already put most of these good graphics into this presentation. So once again, let's go through a few more of these graphics. Here's the idea of, well, this is actually a double loaded office or a single loaded office where we have the benefit of windows on both sides, but this could easily be a hallway here. And you can see this idea of a graphic representation of the intensity of the light fall off from the window to the work surfaces. This relationship of 17 meters, this is a meter, so we're talking about, you can multiply it basically by 3, so you've got about 60 feet of width, and this is about 22 feet, 24 feet of width, so we can bring illumination in, but really we need to start beefing this back up again with auxiliary lighting. Now, that idea of work surfaces is kind of a change. Illumination on work surfaces is kind of changing because the monitors being lit themselves. So if we're not working on paperwork, we're just looking at monitors, low levels of illumination might be really quite acceptable and maybe even appreciated by some. So I think this is kind of a moving target. A lot of what we do with lighting analysis and planning is going to be at the floor plate level, and the idea of the basic organization of spaces to make sure that work areas can be close to glazing systems, and areas that don't need lighting, conference rooms, bathrooms, circulation systems, all of that can be towards the interior of the building. Then the idea of orientation strategies, the aspect ratio, how much, obviously if the light was coming from the south and you only allowed this small part of the building to be exposed, you wouldn't be able to take advantage of this long facade to collect all of that light. So this, and so here we go, we have we can see the orientation of the buildings is in a more general north-south orientation to take advantage of that. We wouldn't want to be laying the building out in the other direction. unless, of course, we were trying to really mitigate the amount of sunlight coming in the windows because of solar heat gain. But that's another discussion. So there are other kinds of software that I want you to be aware of. Echotech, it's mentioned a lot. It really is a more sophisticated analysis of lighting on work surfaces. And you can take your Revit or BIM model and run it through Echotech to get this idea of radiance levels within interior spaces. Just another nice graphic from that linkage that I just showed you that we started out with. The idea of this light well, but in this case the light well doesn't have to be a straight cut. So here we've cut through floor plates through the building at different points. So we can have larger floor plates and smaller floor plates at levels to mix up and break up the visual interior. Another nice graphic of lighting being driven into the building, either through clear story areas, light wells, direct illumination, light wells down deep into the building. So I thought this was a really neat, nice graphic. So with this idea of daylighting comes LEED. I think it's Leadership in Environmental Energy Design. Well, it's a class, and I hate that I'm fumbling over LEED. We'll explain it of the acronym, but it's our guidepost to making sustainable, energy-efficient buildings. So you get points for natural lighting, quality of how much natural lighting with respect to artificial lighting, and so daylighting factors into important considerations if you're trying to get LEED accreditation for your buildings, which is becoming increasingly the standard for for architectural design work. And they have some resources for that. So effective daylighting in LEED version 4.0, and this is a hyperlinked article, I think, that describes that. So I invite you to link on through it, and you'll see a lot of the same concepts we've already discussed. Another link to a similar thing. And this is not limited, and so I also wanted to introduce this idea that lighting analysis is not limited just to BIM, but Rhino has other tools. Rhino is another modeling environment that's quite popular, and it has plugins. One of them is called Honeybee, which allows for detailed analysis of illumination in interior spaces also. So I'm just trying to keep the perspective of this idea that it's not all Autodesk, it's not all Revit. There are other manufacturers and producers of that, and this is a hyperlinked YouTube video. So that concludes basically our daylighting, and we'll pick up with artificial lighting next.